Yeah, so we'll be starting within 2 minutes. So let's wait for other people also to join. Yeah, so I guess we can start. So today will be the last session for the today's for this semester um, interactive sessions, and then I think you people are having the exams from next week. So uh, exam from next week. So let's have a look on all the sessions which we had so far, and let's pick up some important questions, and then let's have a look on them and quickly let's brush up on that. So let's start with this. So let's go to the week one. So I'll just change this thing. Yeah. So um, so let's have a look. So starting from week one. Yeah. So let's starting from week one. So week one was basically about the some of the fundamentals which we had seen. So it's just about the fundamentals which we have covered in the soil mechanics part. So having a look upon that, so yeah, there you can have some of the questions which are based on the type of the soil, uh, and it's very basic origin from the start, and some of the questions link with like how the formation of the soil has been taken place. So this you can refer in the lecture one or the lecture zero, week zero sessions, and week one sessions for addressing this type of questions. Then here you are basically having the the correct option from the following for the degree of saturation in soil mechanics is, so it's more about the composition of your soil, air, and the water. So how the different proportions will basically leads you to get the some of the index properties of the soil, and how the various relations are being utilized in the soil mechanics field to address some of the major application problems. So this is about the degree of saturation. So degree of saturation we know is given by the volume of the voids, volume of the water to the volume of the voids. So you are having two types of voids. One is the air void, and then you are having the water void. So water void with respect to the volume of the water will give you the degree of saturation. Then let's have you want to analyze the grading of the soil. So how you will basically do that? So there are two basic parameter, which is the coefficient of the uniformity and the coefficient of the uniformity and the CC value, CU value and the CC value. So this basically you will utilize to know about how, in which like in your soil matrix what size of the particles are largely available. Then you will basically analyze the effective of the stress in the soil is defined as, so the very basic definition of the effective stress and all other parameters. Then you need to see upon the Moore Coulomb failure line, so the intercept on the shear stress axis represent. So you have need to have a look upon that. Then these are some of the index properties and the relations between that. So void ratio, degree of saturation, water content, and specific gravity. So let's say if any of the parameter is given to you with the help of the other two parameters, how you can derive that. Also there is some of the relations which are available between these index properties. So the dry density, density of the water, uh, void ratio, specific gravity. So you can utilize this particular relation. For example, for the dry density, you can directly, if you are given with these parameters, you can calculate the dry density, or with the help of the dry density, if other parameters are given to you, so how you can derive the that parameter. So vice versa. And then for the data given in the problem 6, then the degree of saturation of the soil sample is. So similarly you can help with, you can get it from the degree of saturation. Then you need to look upon the relative density. So if you are given with the void ratio, so how the maximum, minimum, and the in situ void ratio, so utilizing that you can basically calculate what is the relative density of the soil available at site. Then you are basically given with the coefficient of the volume change. So if you are basically given with the change in the void ratio, if change in the effective stress, so you need to derive what is the coefficient of the volume change, so you can basically utilize this relation to get that. And then you will be having the some of the questions which are related to the effective stress. So in the to basically any ground when you are interpreting the soil mass, so it will basically soil mass up to a certain depth, so it comprises of both your soil particle as well as the moisture and the water in that. So how to basically analyze the stress conditions if you are having the both the this type of having a this complex composition. So in this case we basically utilize one of the parameter which is known as the effective stress to better get the relation. And these are some of the similar questions based on that. Yeah. So this was just about the week one, where you are basically analyzing, interpreting the very fundamentals of the soil mechanics, which will be utilized in addressing some of the application problems in the foundation engineering. Moving to week two. So addressing problems of week two. So in the week two, you need to address some of the questions. So here it basically links with the calculation of the bearing capacity of the soil ground. So if there is a water, groundwater which is available. So let's say if the water table is available at very larger depth. So in that particular case, your water table basically won't disturb the bearing capacity, and in that case you can basically neglect the effect of water table. Then yeah, if the shallow footing is subjected to certain type of load, so what all type of the failures which can occur into your ground. So you have to look upon that. So that is basically you are having the general shear failure, your local shear failure, and then you are having the punching failure. So you have to look upon the definition of each one to better know how the failure lines basically evolves as the load on the shallow foundation keeps on increasing. And then it comes to the minimum. So again, how the bearing capacity uh, um, is available, how the bearing capacity train follows uh, along the ground or with respect to depth on the ground. So you need to have a look upon that. And then yeah, I have talked about that. So as soon as your failure line basically evolves under your footing when it is subjected to some vertical load, so in that case you are having radial shear, which is basically so you are having different types of zone. So one will be elastic zone, then you are having the uh, plastic zone, and then you will be having the radial shear zone. So all that you need to take into account. So now without utilizing those bearing capacity equation, basically you can calculate what is the bearing capacity is. So now considering the following statement, so bearing capacity of footing on a clay does not significantly get altered by the presence of water table. So yeah, we have already discussed this statement above. Then coming to like you are having given with the two types of web footing D1 and D2 which are resting on the surface. So what is the ratio of D1 and D2? Again, like how so sensitive your soil is, so how can you define the sensitivity of so whether it's the percentage of volume change of the soil under saturated condition, ratio of the unconfined compressed strength to of the undisturbed soil to that of soil in rebolted state, ratio of volume of void to the volume of solid. So that's how you need to look. Then how there are different stresses. So usually like to analyze a certain soil, so you will basically in, also interpret that soil material in the lab, so you can take an elemental level of mold in the lab and then subject it to certain type of uh, stresses, and then you can get the condition of the soil block, how it is getting behave, how it is behaving in a very small portion. So that's how you can solve this. Then you can have some of the questions related to the porosity and the void ratio. So your void ratio is basically the volume of the void to the volume of the solids, while your porosity is more about is your how permeable is your soil is, or how porous your soil is. So that is about your volume void to the volume of total volume of the soil. Then there comes some questions related with the consolidation. So consolidation is a process where your soil is subjected to certain external loads. So there can be dissipation of the excess pore water pressure. So that dissipation of the excess pore water pressure, uh, dissipation of pore water pressure, basically can be calculated with the consolidation theories, and on the basis of that you can get the questions. Some of the most popular questions which you will get is basically based upon, so let's say this is property to the soil which you are having right now. So how much time it will take to consolidate, if the degree of the consolidation is this. So again, uh, there are some relations which you can get with the equations available there. Again, it's the type of the soil which we are talking about. Yeah. So that was all about the week 2 which we have discussed. Do we have any? Do we have any participant now? No. Okay, then let's move. So let's move to week 3. So let's talk about, so if you are having a certain isolated footing which is resting on the soil, so you need to basically analyze how much is the pressure which is getting developed at the edges and at the center of the footing. So that is how, so in your rigid footing and both in the flexible footing, so in both the type of footings, the pressure distribution and the settlement distribution will be different along, especially. So that type of questions you need to interpret. Then you are having the bearing capacities, so that you need to work upon. So you are having different types of bearing capacity which is basically used in the design. So one is the ultimate bearing capacity, so how much is the total bearing capacity which your soil offers. Then the net ultimate bearing capacity, which basically accounts for the removal of your capacity which has been offered by the overburden. Yeah. So that you neglect in net ultimate bearing capacity. And then we are talking about the net self bearing capacity. So net self bearing capacity basically deals with like what is the allowable uh, load which your foundation can resist, accounting for your factor of safety which need to be used in the design. So that is the net self bearing capacity. And then when we are talking about the gross safe bearing capacity, so gross safe bearing capacity again, in your net safe bearing capacity, when you basically remove the surcharge, so that will basically talk about your gross safe bearing capacity. Oh, when you add surcharge, not remove. When you add surcharge, so in that case, it's the gross safe bearing capacity. Yeah. So these all are relations available here. So first you'll be having the ultimate bearing capacity, and if you remove the surcharge, so that is the net ultimate bearing capacity. Then if you take into account the factor of safety, so that is basically your net safe ultimate bearing capacity, and then this is your gross safe bearing capacity. Yeah. So these are some of the typical questions based on this. So if you are having a certain type of foundation, it's when it is placed in the cohesionless soil for five the mere of bearing capacity factors. So again, like for the bearing capacity formula also gets changed with the shape of your foundation or your presence of the water table, and also it depends upon the your depth of the footing or your load inclination. So in all the cases, you need to take those corresponding correction factors into account to basically address the bearing capacity formulations. So yeah, that was about the bearing capacity. Yeah, and these are like some of the correction which will basically apply to get the corrected bearing capacity. Then again, these are some of the questions based of the ultimate bearing capacity when your groundwater table is included. So that's how, and when your shape of the footing is different. Yeah. And also in the case when your loading is eccentric, so how to calculate, take into account the maximum bearing capacity or the minimum bearing capacity. Then you'll be having the influence factor. So yeah, so also there are some cases where you need to also calculate how much is the settlement of the footing which is happening. So for the immediate settlement, or for the settlement happening to the consolidation or the secondary settlement, so how you basically take those factors into account. So now there are different methods. So uh, the some of the methods you can read about. Yeah, again, these are about the consolidation. So primary consolidation, your secondary consolidation, and then your creep will basically come. Then also your settlement is uh, can be related with the variation in the void ratio in the soil. So with the help of this particular relation, you can basically account for how much settlement is happening if that much change in the void ratio is observed. Yeah, so that was about the week 3. So we'll take break for 2 3 minutes and then we can continue. Yeah, so I think we can start. So moving to week 4. So your week 4 basically deals with the problem of some of the fundamentals and also the settlement of the footing. So some of the questions were based on the consolidation settlement. So first it was about the over consolidation ratio. So how you will basically define the over consolidation ratio. So over consolidation ratio is none other than like how much stress your soil has experienced in the past and what is the condition right now. So it's basically the ratio of the past maximum vertical effective stress to the current vertical effective stress. So that will basically tells you how much the preliminary strength of the soil mass which is already available there. And yeah, so these are some of the questions about the consolidation, over consolidation, and the pre-consolidation pressure. Then some of the question basically links with like how you will take into account the which is happening settlement which is happening due to the consolidation. So if you are given with the how much is the change in the effective stress which has been happened due to some of the uh, external load, so you can take into account or you can tag that. And also if you are having what is the uh, initial depth of the soil layer, so in that case you can calculate the consolidation settlement if you can take into account the parameter of the coefficient of the volume compressibility, which can basically tells you like how much compressible is your soil is. Uh, mm, by utilizing that particular parameter you can calculate how much is the consolidation settlement of the clay layer. Then also you can calculate the immediate settlement as well. Then this is the consolidation settlement. Then you can take into account the influence vector diagram for calculation of the immediate settlement. Yeah, this is one of the keys in Sherman's influence diagram methods to calculate the settlements. So in this is one of the depth factor which need to be taken into account. Again, these are some of the questions related with your consolidation settlement. And yeah, then your time factor formulas also depends upon how much uh, your degree of consolidation which you need to address. So if the degree of consolidation is between 0 to 60 percentage, so that is the particular relation. If the degree of consolidation is greater than 60 percentage, so that is particular relation. So that was all about week 4. Let's move to week 5. So in your week 5, the questions are basically based upon the earth dam constructions. It is more about the soil investigation techniques here. So let's say if you're constructing a dam, so how much the borehole depth which you need to take into account for the borehole depth investigation, then how your CPT basically works, then what is the time factor for clay layer is, and let's say when you collect the uh, soil samples from the real field, so how you are taking into account the disturbance of the soil samples. So it's basically more interpreted with the help of the instruments which you are using for collecting that soil sample. So in this, one of the parameter which we take into account is the area ratio. So area ratio is none other than is your what is the external diameter of the tube, and then what is the internal diameter. So that is the thing. Then in some of the questions which you will take into account, like calculation of your settlement of the soil layers, so which is located not just beneath the footing but at a certain depth. So how you can basically take into account the settlement. So that basically is interpreted like by assuming that the increment in the vertical effective stress is happening in the ratio of the 2 is to, in the ratio of 1 is to 2. So let's say if you're moving 1 meter depth, so the increment in the vertical effective stress is 2 will be twice. So and that's how you can calculate the change in the effective stress, and then you can utilize the same formula which basically gives you how much is your total settlement due to consolidation. So that's how you can basically utilize those formulas to calculate the settlement at for a soil layer which is located at a certain depth. So this is your total settlement of the footing. So now the another set of the question which will be addressed again will be related to the degree of the consolidation. So we have already discussed it. So usually in this case you need to first evaluate how much is the degree of the consolidation. So degree of the consolidation at a certain time basically known as uh, how much is the settlement of your soil layer has happened, and what will be the soil set to the and then it is compared to the how much settlement of the soil layer is going to happen throughout the lifetime of the structure, or let's say when the that soil is available. So that's how we can calculate the degree of consolidation. Then next basically talks about the coefficient of the consolidation of the soil sample, so that you can take. Then again, time factor will basically help you in calculate the coefficient of the consolidation. Then you'll be having the time to require for attaining a certain degree of the consolidation, how it is depend upon the thickness of your soil. And in the pile foundation construction, how much is the borehole depth is. So again, that is about your this thing like more about the soil investigation. And again, if that much variation in the effective stress is happening, so how much it is leading to the basically variation of your settlement of the soil layer. Yeah, so again these are about the calculation of your time factor for two cases. So that is one important thing which you need to take into account. So if the drainage of the soil layer is there on the both the ends, so you need to consider uh, only half of the soil layer while calculating for the time of drainage, while if the permeability or if the drainage is happening only at the one end, so in that case your soil layer your whole soil layer depth need to be taken into account. So that was about week 5, and when now we are moving to week 6. So week 6 1 2, okay, I haven't downloaded week 6. Let's check for the week 6. Yeah, so now let's move to the week 6. Yeah, so week 6 basically again having some of the questions related to your soil investigation technique. So these are more about the geophysical soil investigation technique. So how using the different analyzing the different seismic waves into account, you can basically analyze the property of the soil beneath the ground. And yeah, utilizing, like if you are given with a certain internal friction angle, so how you can basically calculate the earth pressure coefficient. And again, this is also about one of some of the questions related to your evaluation, uh, how you are basically stabilizing your earth retaining walls. So using the reinforcement, you can, or nailing or anchor system, you can basically reinforce your earth retaining wall. Then if you want to calculate the lateral earth pressure, so how you can take into account the different earth pressure coefficients. So if you want to evaluate the lateral earth pressure, the lateral active earth pressure or lateral passive earth pressure, or the lateral pressure at rest, so how you will basically calculate that. And also, if you are having the inclination angle, or if you are having the uh, internal friction angle phi, so how you will basically calculate the earth pressure coefficient. And if you are having different electrodiodes which are available, so by placing them into the soil at a fixed depth, a fixed spacing interval, so how you can calculate the electrical resistivity of the soil. uh, and again, these are some of the question depends on the earth retaining wall. So by utilizing the earth pressure theories, basically you can calculate how much is the total pressure which has been applied by the soil for on the retaining wall. So yeah, these are some of the uh, de- another soil investigation technique, which is the vein shear test, which will basically helpful in analyzing the undrained shear strength of the soil. Then this is one of the some of the questions which is based upon the calculation of the maximum depth of the excavation. So how much excavation which we can do in the soil without such that the soil doesn't collapse. Yeah, so that was about week 6, which basically deals with the earth pressure theory and the retaining walls. Then let's move to week 7. Now week 7 again basically revolves out earth pressure theories. Yeah, so let's move to week 7. So how much is the maximum possible depth? So if you want to excavate, if you want to do a deep excavation, so we are having the cohesion available with us, the unit weight available with us, and the earth pressure coefficient available with us, the active earth pressure coefficient. So how to calculate how much is the maximum possible depth which we can dig into the soil. Then again, the calculation of the active earth pressure. So if you are having a retaining wall which is 6.5 meter high, and your cohesion, friction angle, then how and your unit weight. So how to calculate depth of the tension crack. This is your key calculation of the active earth pressure coefficient and how to take into account for your development of the tension crack. So how much your tension crack has been developed. So if you are given with a retaining wall and if there are two depth soil layers, so how to take into that take that thing into account. Again, this is about the active earth pressure, uh, the both your passive and reactive earth pressure. So that was about week 7. Let's move to week 8. So week 8 is about your D foundation. One of the D foundation which we have taken into account is the pile foundation. So where we'll basically utilize the pile foundation. So pile foundation is basically consider pile foundation is basically considered in the scenario when you want to transfer the loads at very larger depth. So in that case, you basically take the pile foundation into account. So when the loads are heavy and you want to transfer your load to a larger depth, so yeah, pile foundation can be used. Then how to calculate the capacity of the pile. So it basically depends upon the soil in which it is placed and also the material and the geometrical property of the pile. So also again the pile basically resists the overcoming load above it using two factors from the pile to from the end bearing capacity and from the shaft friction. So with the P basic shaft friction, you can calculate how much is the shaft friction capacity available, and by analyzing the capacity of the soil beneath the pile 2, we can calculate how much is the end bearing capacity. So if we are having a pile which is of a square cross section and the unconfined compressive strength is 80 kPa, so what is the net ultimate bearing capacity? So that also you can calculate. And yeah, so how to calculate the ultimate bearing capacity? So ultimate bearing capacity basically will comprises of both the things, your uh, shaft capacity of the pile as well as your shaft friction capacity of the pile as well as your end bearing capacity of the pile. And if your water table is present, then again your effective stress variation will get changed. So also the shaft friction capacity will also get changed, because it depends upon your effective stress of the soil available or its variation along the depth. Then you do need to calculate what is the bearing capacity, the value of the bearing capacity factor. Then if you are having the coaged soil, and if you are having the frictional alpha values, how to calculate the pile capacity when you are having both the shaft friction as well as your end bearing. Again, your when the cross section of the pile is getting changed, so again your shaft friction calculation, also your end bearing capacity calculation will also get changed. So that was about the pile foundation, which we have discussed in the week 8. Then let's wait for 5 minutes and then we can go further. So now it's about the calculation of your uh, capacity when there is not a single pile but a group pile. So we also register the load coming from the superstructure with the group piles. So when you are given with a 14-meter long pile which is having a 300 diameter, the phi dash is equals to 40 degree. So you are having a 14-meter long pile which is a 300 diameter pile which is driven into a uniform deposit of sand with a friction angle of 40 degree. The water table is present at 2 meter depth below the ground surface. The unit weight of the soil above the above and below the water table are 16 kilonewton per meter cube and 20 kilonewton per meter cube respectively. The unit weight of the water is 10 kilonewton per meter cube. If the NQK delta, the ultimate pile load capacity is. So in this case, let's say when you are having a different type of soil with different thickness, so you can basically evaluate the frictional capacity of the pile for the first step, then for the second set of the soil, and then the third set of the soil. You can evaluate how much is the capacity available, and then you can calculate the frictional capacity of the pile. So this is the QF. So how basically you use the pile load test. So pile load test is basically utilized to evaluate the ultimate bearing capacity as well as to evaluate the settlement of the pile. The efficiency of the pile group basically depends upon both the characteristic of the pile, the spacing of the pile, and the type of the soil. When you are having a 300 diameter pile and 10-meter long pile, which are used as a foundation for column and a uniform deposit of the clay, with cu is equals to 50 kPa. The spacing between the pile is given as 750 and there are 9 piles in the ground. So how do you calculate the capacity of the piles? So you can utilize the efficiency of the pile group. So efficiency of the pile group is basically how much together your all piles can resist the upcoming load, and also as compared to when all the 9 piles are taken with their individual capacity. So that particular ratio is basically give the efficiency of the group. So coming to next, so you are having a group of 9 piles which is 10-meter long, 300 in diameter, and it is arranged in a square pattern in the clay soil with an average unconfined compressive strength of 60 kPa. What is the ultimate load capacity of the group piles on the basis of the individual action and without considering the efficiency factor? So assume adhesion factor is 0.9. So pile group is basically calculated using the frictional capacity of the pile. So in question number 4, what is the center to center spacing of the pile if the group efficiency factor is 0.7? So which of the following formula can be used for determining the efficiency of the pile group? So which of the formula you will take into account for determining the efficiency of the pile group? Dynamic formula, static formula, converse level formula, or Hillis formula? So how to calculate the ultimate bearing capacity of the pile? So you know about the shaft friction, you know about the end bearing, so you can calculate how much is the ultimate bearing capacity. So for freestanding, the pile group having 10 value of d by s is 18.5 degree. The efficiency as per the converse Labrador formula, so that's how you can calculate. So you know m, the number of piles along the row, number of piles along the this, so minus 1 plus n into m minus 1, so that's how you can calculate. So the load carrying capacity of an individual friction pile you know is 200 kilonewton. So what is the total load carrying capacity when a group of 9 piles are taken into account with the efficiency factor of 0.8? So you know the capacity of single pile, you can know the capacity of the you know the efficiency factor, so that's how you can calculate the capacity of the group. And now again, like ultimate bearing capacity for single pile. So this is the question based on the single pile. Moving to week 9, moving to week 10. Now it's about the sheet pile wall. So if you are having a sheet pile wall, so how much is the passive resistance of the soil? Then how does the anchorage system basically supports? So support of the anchor sheet pile wall basically comes from the passive resistance of the soil as well as your anchor rope. And also, like, how can you model like the anchor sheet pile wall? So we can see that the sheet pile wall basically resist uh, the load, which it resists the pressure which is coming from the soil beneath by utilizing the capacity offered by the soil in which it is embedded. So when it is having a very lower depth at which it is embedded, so we can almost see that the sheet pile wall is moving, so we can consider that thing as a roller support condition. Now here you have been asked like to analyze whether your sheet pile wall is in which zone is your active state zone. So active state zone is basically that zone when your uh, pile sheet wall or the cantilever sheet pile basically moves away from the soil. So we can see that in the first case your sheet pile is basically moving away from the soil. So yeah, that is your case of the active condition. Okay, the correct answer should be C, because in the first case your soil pile wall is basically moving away from the soil, and in the third case your pile wall is basically moving away. So in both the first and third condition, your sheet pile wall is in active state condition. So as compared to the cantilever sheet pile, the required depth of the anchor sheet pile below the dredge level is less. Yes. So now you need to determine how much is the point of the zero pressure will be at a depth below the dredge level. So point of the zero pressure is basically depends upon how you will take into account the earth pressure diagram. So in here you can see your earth pressure is basically increasing. Now it's the shape is getting changed. And then you are having struts which are available, which basically stops wall from moving. So the components of the brakes acceleration is are all of the your yeah. So first let's focus upon this the point of the zero pressure. So how you will calculate. So we basically need to determine when your earth pressure diagram is getting changed. So from one condition from where it is basically moving from passive to active state. So here you can see the up to this depth your soil pressure is in this direction from left to right, but here you can see from right to left. From but below this point you can see the earth pressure is basically from the left to right. Now, like analyzing the components of the brass acceleration, so it is basically all of the above. Here we can see this section is your sheet pile, and this is your struts, and the joint which is basically coming connecting the sheet pile and the strut is basically known as your wheel. So this is about this. So now in the case of for the anchor sheet pile wall shown in the figure and below the water table, the saturated unit weight is gamma sat is 19 kilometer meter cube. Consider unit weight of the water as 10 kilometer per meter cube and friction angle is 30 degree. What is the total active earth pressure is? So it is 1.5 meter, 3.5 meter, and 2.5 meter. Yeah, again, these are based on the similar theories where your earth pressure basically changing its direction, and then you can calculate how much is the passive earth pressure and how much is the pressure in the road. So pressure in the road is none other than like how much is your passive pressure and how much is your active pressure. So the difference between both of them is the force which needs to be resisted by the anchor. Let's move to week 11. Moving to the week 11, so here it depends upon again the earth pressure. So how you will basically design the brace cut. So it depends upon your apparent pressure diagram. So we can see how the apparent pressure diagram basically looks like. So these are basically utilized to for the designing of the trench. So you are having 3 meter wide trench, 7.5 meter long. The side of the trench are supported with a sheet pile wall. Yeah, you know that. Assuming gamma is 18 kN per meter cube and phi is the 30 degree, what is the maximum pressure against the sheet pile wall is? So let's say at the base it's 0.65 H gamma K. So that will basically tells like how much is the width of the apparent pressure diagram, and we can basically calculate what is the maximum pressure. Yes. Again, these are again based on our apparent pressure diagram. So here you have been asked like how much is the maximum strut load with the horizontal spacing. So these are struts. So when the horizontal spacing is so these struts are basically placed in both the directions along the vertical axis and along with the horizontal axis. So along the vertical axis the spacing is 1.5 meter, and the spacing horizontal also the spacing is given to you. So that's how you can calculate the maximum strut load with the horizontal spacing. Now you have given with the spring coefficient and the mass of the system. C is given to you as deforming coefficient. The system is under damped under what condition? So C by 2m is given to you less than root over K by m. So C critical. C critical is known as and your 2m omega n. So yeah, usually for the under damped condition, your C by 2m should be less than root over K by m. Then this is about the permissible amplitude of the reciprocating machine. Then this is the case where basically you design to avoid the resonance. So how do we define the structure such that its natural frequency lies in a certain range? And this is again the equivalent stiffness mass system. And here it depends upon the natural frequency of the system. Yeah. So again, it depends upon the spring mass dashboard system. What is the maximum displacement of the vibrating system? And again, question based on the machine foundation system. Again, this is a spring mass system. You need to take into account for calculation of the oscillation of the mass. Moving to week 12. So let's cover the last slide for today. So uh, again, it depends upon the like calculation of the under dam system, over dam system. So under dam system, we know when your C by 2m is less the root over k by m, so it's under dam system. uh, then it depends upon the then another question which you can get is like the calculation of the damping factor. So how to calculate damping ratio, so it depends upon uh, the static oscillation along with how much is the maximum oscillation. So that's how you can take into account. So in this case, when damping when usually small, less than 1.1, so your damping become very small, less than 1. And again, these are based on the stiffness mass system, so that's how you can calculate natural frequency. And then there are relation between the natural frequency and the damp frequency. So damp frequency is none other than your relation of natural frequency root over 1 minus I square. And if you know like the amplitude of two consecutive peaks, so you can basically utilize that to calculate how much is your damping ratio. And this is again question based on the apparent pressure diagram, and these are the question based on the strut valve system. Yeah. So I think that was all. So those who are watching this video at the later stage, you can post your queries in the comment section of the YouTube video which I'm going to upload. I'll definitely address your query over there. And this was the last video which basically covers a quick brush up of all the questions which we have done in our previous sessions. So you can again go through all of them once again. So uh, you can post your query again like in the comment section of the YouTube video. So you can post your query in any comment section of the YouTube video, mentioning the session for that particular week and the question number. I'll look into that and definitely address your query over there. So thank you so much. So with this session, we are basically closing the interactive sessions for this semester uh, and for this particular course. So it was a lovely experience to interact with you. Uh, Thank you to all who have joined earlier, and thank you to all who are watching these videos at a later stage after the video has been recorded. So thank you so much for your support. We hope we will have similar sessions. I'll get the similar sessions in the future. So thank you so much.